Hello! Yes, and let's do some sample problems for Objective 2.2 that says I can graph angles in standard position. So today what we're going to do is we're going to graph some angles in standard position and just get some more practice in with this idea. So let's start here with these first set. Draw an angle with a given measure in standard position, state the quadrant the terminal side is in. Awesome. So let's start here. So if I want to draw negative 40 degrees, well, I know that a quarter of a rotation would be negative 90. So I want to put my terminal side right between there. Since I'm going negative, I'll go this way. And then I will say that this is negative 40 degrees. And that ended in the fourth quadrant. All right, 250 degrees. So I know that half of a rotation is 180. 3/4 is 270, so I'm going to be a little closer to the 270, right about there. This is positive, so I'm rotating counterclockwise, and I will say that this is 250 degrees. I ended in the third quadrant. 140 degrees, well, I know that a quarter of a rotation is 90, half is 180, so I'm going to get pretty close right in the middle of those. There's my terminal side, and of course, my initial side is always on that positive x-axis. This is positive. And then I would label this as 140 degrees. That one ended in the second quadrant. So those were degrees. Let's do some in radians. 7 pi over 4. Well, I know that 8 pi over 4, or 2 pi, would be a full rotation. 6 pi over 4 would be 3/4, right? Because this would be 4 pi over 4, and this would be 2 pi over 4. So if I want 7 pi over 4, I want right in between 6 and 8, just like that. So there are our two rays. We're positive, so we'll go counterclockwise like so, and then label this as 7 pi over 4. I ended this one in the fourth quadrant. Negative 5 pi over 4. Okay, so the same intervals, only this time, let's see, we'd have negative 4 pi over 4 here. Remember, we're rotating this direction, so that means negative 6 pi over 4 would be up here. Oh, negative 64, negative 6 pi over 4, there we go. And that means that negative 5 pi is going to split it right down the middle there. I have my positive x there, negative rotation, so I'm going clockwise, and then I would label this, of course, negative 5 pi over 4. 2 pi over 3. Okay, so this one's a little trickier because 3 is not so evenly distributed as 4. But I know that this is pi, so this would be 3 pi over 3. This would be half of that, so 1.5 pi over 3. So I know that 2 pi over 3 is going to be just a bit past there. I'm positive, so I'm going counterclockwise, and I would label this 2 pi over 3. And this ended in the second quadrant, as did the last one. So there's some graphs limited to one rotation, but what happens if we have graphs that are more than one rotation? So for this one, we want to find the coterminal angles between negative 360 and 360, then graph the angle. So negative 480 is obviously too low right now, so let's add a positive rotation. So let's add 360 degrees. Negative 480 plus 360 would give me negative 120. So there's one. Now there will generally always be 2, so I can add negative 120 plus 360. That one would give me 240 degrees. So there are two coterminal angles between negative 360 and positive 360 for this original angle of negative 480. So when I'm graphing this, I can think, okay, 240 degrees. Remember, this bottom one here would be 270, so I'm not going quite that far. So that's where my terminal side would be. Now let's add the correct rotation that we need. We want negative 480. So we're going to do an entire negative rotation and then in there. So this would be our negative 480 degrees. Now, the fun part here, they ask for the quadrant, easy. Third, the reference angle. So they want us to find this angle here. So this requires a little bit of math. We can think if this was negative 120, right? Same thing, negative 120. So this right here is 120 degrees. That means this must be 60 degrees to get 180 from that full rotation. Okay, so there's one. Let's try another. 650. This one, too large, right? So I'm going to subtract 360 degrees. So 650 minus 360. What would that give me? 290 degrees. So there's one coterminal angle. Let's find another, 290, and then we can subtract 360 from that, give us another negative rotation, negative 70 degrees. Oh, that's going to be really easy to graph, right? Negative 70 degrees, we can do that one pretty straightforward. So that one would be right here. Negative 70 degrees, right? That would be this section here, negative 70. But we want, remember, that's not the angle we're graphing 650. So that means we did an entire positive rotation, that's 360, and then we keep going to here to give us that 650 degree. So what quadrant did we end in? We ended, oh, I don't know, what just happened there? 650 degrees. We did an entire positive rotation, and then we continued on to the fourth quadrant. My reference angle, this is where this gets really handy, right? Negative 70. So I know that this right here was negative 70 degrees, so that means that this is 70 degrees. Our reference angle is always positive. Think of it as the absolute value of that angle. It'll always be between 0 and 90. Okay, last one, 690 degrees. Negative 690 degrees, oh boy. So, let's see here. Negative 690 is way too negative. So if I add 360, I think I'd get negative 330, but let's double check. So, negative 690 plus 360, we get negative 330 degrees. So there's one coterminal angle. Now if I do negative 330 plus 360, that one will give me 30 degrees. There's another one super easy to graph. This is why those coterminal angles are so helpful. Instead of graphing negative 690 degrees, which is very difficult, we can say, I'm going to graph 30 and then just do the rotations for negative 690. So 30 degrees is just a little into our first quadrant, like so. I already said it's our first quadrant, so that's nice. Now remember, we're really graphing negative 690, so we're doing an entire negative rotation, and then almost another entire to give us that negative 690 degrees. My reference angle, again, another reason coterminal angles are so nice. We know that that one's going to be 30 degrees. This one was 70, 30 degrees. There we go. Awesome. Hopefully we're feeling confident with these. These were all in degrees. Let's do some in radians. I think that'll help also. So let's say this time we want our angles between negative 2 pi and 2 pi. So 35 pi over 9, way too big. Think about we need to subtract 2 pi, which in this case would be 18 pi over 9. So that would give us 17 pi over 9. And then we can subtract 18 pi over 9 again, and that would give us negative pi over 9. So we have one coterminal angle at 17 pi over 9, another one at negative pi over 9. That makes it pretty easy to graph, all things considered. So negative pi over 9 would be just a slight little angle going down that way. Now, however, remember, that's not the angle we're graphing. We're graphing 35 pi over 9, so we need the positive rotation all the way to there. 35 pi over 9. Beautiful. Okay, so what quadrant did we end up? We ended up in the fourth quadrant, and what would that reference angle be? So remember, we want this angle here, which happened to be that negative pi over 9. So we always use the positive, so it would just be pi over 9. Very good. Let's try another. Let's look at negative 11 pi over 4. So this time, if I want to add 2 pi, that would be 8 pi over 4. So that would become negative 3 pi over 4. So there's one coterminal angle. And let's add another 8 pi over 4. And that would give me 5 pi over 4. Fantastic. So now let's graph either negative 3 pi over 4 or 5 pi over 4. Both of those are pretty straightforward. They're going to split right down the middle of that third quadrant. Now I'm graphing, remember, negative 11 pi over 4. So I'm going to have one entire negative rotation and then get me to there. So that would be negative 11 pi over 4. My reference angle would be this angle here. So if I remember that this is 4 pi over 4, I went 1 past there. So this would be just 1 pi over 4. Very nice. And our last one, 8 pi over 3. So I'm going to subtract 2 pi, which in this case would be 6 pi over 3. So that would leave me with 2 pi over 3 as one coterminal angle. Now, of course, there is another. I can subtract 6 pi over 3, and that would give me negative 4 pi over 3. And this is an angle I think that we actually graphed earlier. It would be in our second quadrant for 2 pi over 3, something like so. However, I'm doing 8 pi over 3, so I need one entire positive rotation, and then we'll end there to give me 8 pi over 3. So I ended in the second quadrant, and this reference angle, that would be this angle here, right, with the angle created by my x-axis, that angle there. So if this is 2 pi over 3, this would be 1 pi over 3. So my reference angle in this case would be pi over 3. Very good. Hopefully that was helpful and we have a better understanding. If we're feeling good, go ahead and definitely look at those practice problems. Otherwise, reach out. Ask me a question. Let me see if I can help clarify anything a little better. Graphing these is difficult. It's one of the more difficult things we'll do in this unit. But I think if we get this down, we'll have a really good foundation moving forward. This is Mr. Carter signing off. I'll see you next time.